Here is returning back to our diagram of a loop. This is a diagram that shows a loop. Now what we're doing here is we're measuring. Oh, that's not right. We're measuring. We go up here and we make a decision based on that measurement. And that decision tells us to make an output. And that valve, of course, changes and alters the process, which we then measure, and we use that measurement to make a decision, which, based on that decision, we make an output, which changes the process. What we have here is a loop. It's a complete loop. So we go around this loop again and again and again. We measure, decide, output, change process. Measure, decide, output, change process. And we're always measuring, and our decision is based on measurement. Because our decision is based on measurement, we call it feedback. What we say is we're feeding the measurement back into the decision-making process. Oh. So we have a loop. The loop happily goes round in this direction. We decide, we output, and we change the process. It is a complete circle. It goes round and round in a loop. Because it's a circle, we call it a closed loop. The thing that we're measuring, the thing that we're trying to measure, the thing that we're measuring or trying to control, the variable in the process, we call that the process variable. So the process variable is a thing in the process which we're trying to measure or control. We abbreviate that to PV. In this case, the process variable is the flow. PV equals flow. The way we compare the process variable to what we call the set point, so in here comes a set point, and that is the target. The way we compare the process variable, the way we make a decision is we compare the process variable with the target. What we do is we take the set point and we subtract the process variable. So the process variable is subtracted from the set point, and this generates a thing called the error. What we try and do is we try and reduce the error. If the error is 0, that means that the set point and the process variable are the same. Because we are subtracting the set point, the process variable from the set point, because we're trying to reduce the error, we say that it's negative feedback. Negative feedback reduces the error. If it was positive feedback increases the error. So in control systems, negative feedback is a good thing. Negative feedback reduces the error. It brings the process variable closer to the set point. Positive feedback increases the error, and the process variable goes further and further away from the set point. With loops, you can either have a closed loop system where we monitor the process variable and we use that in our decision-making process, or you can have an open loop system where we don't monitor the process variable. It's a bit like when you drive down the road. If you're driving down the road and trying not to get a speeding ticket, you would drive down the road and your process variable would be your speed. So you would monitor your speed, and you would look at the speedo, monitor your speed, and you would use that in your decision-making process, which would be whether to put your foot down or lift your foot up. On the other hand, open loop control would be if you didn't have a speedo. Open loop control would mean what I'm going to do is I'm going to push my foot down 3/4 of an inch and just hope for the best. And that's open loop control, where you just make an output and just hope for the best. Traditionally, in tertiary education, we've always said closed loop is good, open loop is bad, because closed loop uses feedback. So closed loop monitors what's actually happening. So closed loop must always be better than open loop, which doesn't monitor. Now this is actually incredibly simplistic. To show this, here's an example. I've got two types of street light. I've got the first type of street light, which is open loop. I've got a sensor, a light sensor, on the top of the lamppost. And that's not seeing the light. It doesn't see the light, so it doesn't take the light reading and feed it back into the decision-making process. That's the open loop. The closed loop one, I have the lamp sensor stuck underneath the light, down on the pavement. And it is looking at the light. So the closed loop one does look at the light, so it does use feedback. Closed loop uses feedback, open loop doesn't use feedback. Now, can anybody think of a possible disadvantage of the closed loop system? Yeah, that's certainly the very first possible disadvantage. It's in the pavement. Basically, it's going to get kicked. It's going to get kicked and the dogs are going to crap on it, which is a very bad thing. It's extremely vulnerable. Another big disadvantage, and it's one of the biggest disadvantages of using feedbacks, is you can get, what could happen is the sensor on the closed loop system could say, that's exactly, you just said that, Dan, yeah. What could happen is the sensor could say, oh, look, it's dark, I'll turn the light on. Click. Oh, look, it's light, I'll turn the light off. Click. Oh, look, it's dark, I'll turn the light on. Click. Oh, look, it's light, I'll turn the light off. Click. So closed loop systems, whenever you use feedback, the first thing that feedback wants to do is oscillate. Feedback creates oscillation. Feedback always wants to do oscillation. Whenever you have a closed loop system, what it wants to do mostly is oscillate. One of our biggest jobs as instrument people when we're setting up and we're tuning closed loop systems is stopping it from oscillate. There's very few instances when we can actually stop something oscillating, because mostly feedback just wants to oscillate. It's its happy little place. So that's a big problem with feedback loops. Feedback will cause oscillation. And of course, it's in a stupid place. So, all in all, in this instance, open loop is by far the better application. So when you read in some books, closed loop good, open loop bad, they're just, that's nice. It's TAFE lecturers do come up with these ideas sometimes, but the real world is that sometimes open loop is so much better than closed loop. So we should have got some important terms. We should have known feedback, process variable, PV, which is the value in the process that we want to measure or control, set point, which is the target, closed loop uses feedback, open loop, no feedback, closed loop, we change something, then we check it. and then we change it again. Open loop, we change it and we hope for the best. And these are the terms we should have learned. And that is the end of today's session. So I have nothing more to teach you tonight. If anybody has any questions,